Okay, when you're doing related rates questions, I recommend you follow some of these steps. Read the question, reread the question, and read it a third time if you have to identify what's being given and what's being asked for. You need to be able to identify what's given and what's being asked for. Then I would draw a picture. It's going to probably be some geometric shape. After you've identified what's given and asked for and you've drawn a picture, then you're going to write an equation that involves those variables, be it a radius, a volume, a height, or whatever. Then you're going to differentiate implicitly with respect to time. Only after you take the derivative, then you can plug in instantaneous values. So after you've differentiated, plug in your instantaneous values and solve for what they're asking for. These are the steps that I usually recommend. Okay, I'm going to try this example, and understand this is a harder one because this one involves a secondary equation, but I'd rather you see a challenging one than just give you the easy ones. Okay, so I'm going to look at this question. Water is pumped into a conical tank at a rate of 3 cubic feet per minute. If the tank's radius is 6 feet, the height is 12 feet, how fast is the depth of the water changing when the water is 4 feet deep? Read it a few times, make sure you understand it, and I'm just going to add some things. This radius of the tank, I think we said, was 6 feet. The height of the tank, I think we said, was 12 feet, right? And I do think we said that water was flowing into this at a rate. Anytime you see the word rate, it's a derivative. So it's cubic feet is volume. That means it's giving me dV dt to be 3 cubic feet per minute. That's given. As the water is being pumped into here, it's going to attain a certain height. That's going to have a certain radius here and a certain height here. So basically, they want us to find how fast the depth of the water is changing. Well, the depth of the water would be h. So I think they want us to find dH dt. They want us to find how fast the height is changing. So it's a cone. They give us a change in volume. They give us a height. So maybe I should write the volume for a cone. Volume of a cone is anything that comes to a point, if you remember your geometry, is 1/3 the area of the base times the height. The area of the base is a circle, so it's pi r squared times the height. Now, they give us dV dt. So I want V. They want us to find dH dt. So I want H. Is there a variable that I don't want in this equation? I probably should eliminate the R. That's what I mean when I said this involves a secondary equation. I would like to get this down to simply two variables, 1/3 pi r squared h. If I can get it down to two variables, it makes finding the derivative much easier. So, I don't know if you see this. You have two triangles here. You have a big triangle and you have a small triangle, right? They are similar. If they are similar triangles, that means their sides are in proportion. So could I do little radius to little height? That's R is to H, as big radius is to big height. I did small radius to small height is as equals big radius to big height. Solve it for R. 12R equals 6H. R is going to equal 1/2 H. So I could replace the R with 1/2 H. When I square this, I have to square the H and the 2. So anyway, I get the volume to be pi over 12 h to the third. Now I have it down to two variables. So it's kind of important to do that first. That involved using a secondary equation. Most of your early questions don't involve a secondary equation. Just some of the more involved ones later on will. Okay, once we have it down to two variables. Okay, so I have these. I'm going to get rid of those boxes. At this point, if you remember the steps, you want to differentiate with respect to time. So the derivative of volume is dV dt. Pi over 12 is a constant factor. Power, base, 1 less power, derivative of the base. Because it's an h, you put dH dt. So you'll notice that 3 goes into 12, I think, 4 times, and h squared times dH dt. I'm trying to find dH dt, how fast the height is changing. So I'm going to leave dH dt in the equation because that's what I'm trying to find. Do they give me dV dt initially in the problem up here? dV dt is 3. At the instant, it's how deep? 4. And I can only plug in that instantaneous value after I've taken the derivative. So you get 3 equals, one of the 4's would cancel. I believe it would be 4 pi dH dt. If you were to divide, what would dH dt equal? 3 over 4 pi. If the volume is in cubic feet, the height would be measured in feet. Time is measured in this problem in minutes. I would caution you, notice the pi is in the denominator. It's down here. Many of you are going to be lazy and put the pi on the end. If you put the pi on the end, that means it's on top, doesn't it? So please be aware that the pi is in the denominator, and you need to clearly indicate that. Okay, your assignment in 2-7 in AP Calculus is going to be 11, 13 to 21 all, 24 to 29 all. Number 11 deals with a circle, so I draw a circle. I know circles have radiuses, so I might even draw the radius. Now, the question says the radius of a circle is increasing at a rate of. Rate of means a derivative. It says the radius is increasing, so that's the rate of change of the radius, or the derivative of the radius. They say is 4 centimeters per minute. They want to know, find the rate of change of the area. So this is what's given. What are they asking us to find? The rate, which is the derivative of the area. So please make sure you know what they're giving us and what we're trying to find. Now I want to write an equation that involves area, radius for a circle. So I would hope that you know this formula. I'll give you some of the more obscure geometric formulas, but I hope you know the area of a circle. You do not need a secondary equation in these early ones. There's only two variables, right? So take the derivative of A, you get dA dt, because you're taking the derivative with respect to time. Okay, pi is a constant. I'll keep a constant factor, keep it up front. Power, base, 1 less power, derivative of the base. So dA dt equals 2 pi r dr dt. They want us to find the rate of change of the area, so I leave dA dt there in my formula. I'm going to fill in the other parts. Part A says find the rate of change when the radius is 8 centimeters. So at 8 centimeters, that's an instantaneous value. It's only 8 centimeters for an instant in time if it's increasing. So I can only plug that in after I take the derivative. Now they do give us dr dt to be 4, don't they? So I think 8 times 8 makes this value 64 pi. If the radius is in centimeters, the area would be in square centimeters. And the units of time for this is minutes. So there's your answer for number 11A.